Howdy, we are First Tech Challenge Team number 11524.
Team Name Wanted, dead or alive.
My name is Sophie.
I'm Ty. I'm Toby.
My name is Noelani.
My name is Daniel.
And my name is Benjamin. In this video, we will be showing you how to build a basic robot chassis.
Here are some part suppliers commonly used in FIRST Robotics. The simple yet robust system of Pitsco Tetrix makes it easy to build with and a great starting material for new teams. However, in comparison to other building systems, their parts introduce many design restraints due to the fixed hole pattern. GoBuilda offers a wide range of parts to accommodate different design and building styles. Their parts are designed to be robust and adaptable, which means that most of the parts from other companies like Pitsco, AndyMark, and Rev can be adapted to work with GoBuilda's own parts. Rev's standard extrusion parts are smaller than that of Pitsco and GoBuilda, which makes the design more flexible. Because there are no screw holes, teams can attach separate pieces practically anywhere that they want. Since screws are slid from the end of the channel, building with Rev extrusions is usually more difficult than building with other materials that contain screw holes. Rev now offers U-channel material as well, for teams that prefer the screw hole format. Since Rev is currently one of the most common building systems used by First Tech Challenge teams, we will be using pieces from Rev to create our own robot chassis, which is also known as the body or the mainframe.
Rev Robotics offers a variety of parts that are available for you to use for your robot. Here are some of the common parts that are available from Rev. Rev's plastic gears range from 90 tooth to 15 tooth sizes. These are a few of the numerous plates, brackets, and mounts that are available from Rev. Many of Rev's parts are available in both plastic and metal variants. To explore all of the parts that Rev provides, check out the Rev website. Here are some additional parts and tools that are helpful when building your robot. Not all of the parts shown here are produced by Rev. You can also use parts and tools available from other manufacturers. Our team frequently visits our local hardware store to find a variety of inexpensive materials. Keep in mind that different manufacturers' parts are rarely compatible with each other, so it is more challenging to implement multiple building systems into your design.
Before getting into the interesting stuff, we want to make sure that you and your team have the best proceeding method when it comes to constructing an FTC robot. Now, I will admit that the engineering design process isn't the funnest thing to learn. Even some of our own teammates complain about it. But once we get through the video, you'll be glad to have learned it. This flowchart is a brief replication of the design process. I'll be getting into more detail for each step, and I will try to not make it as boring as possible for you. However, if it does get boring, I do encourage you to pay attention because there is a step in the procedure that I will be talking about that is not shown in the chart. Please feel free to take a screenshot and make a quick sketch of the chart before moving on. The first step in the engineering design process, and what some might argue to be the easiest step, is to define the problem. Before you or your team begin building a robot, you need to make sure that you fully understand the tasks that are assigned to you and what you expect to accomplish. For example, during FTC Skystone season, one of the tasks we were challenged with was to build a highest tower possible using the blocks provided by First. Knowing this, our team understood that designing a robot that had the ability to stack would be more beneficial than, let's say, a robot that climbed. Brainstorming can be one of the most challenging steps in the procedure, more challenging for some than others. This is where you and your team sit down and discuss the many possible solutions to the problem defined in the first step. However, since First is a team-based sport, we are encouraged to remind you that turning down a teammate's idea is not recommended. As stated in the slide, even ridiculous ideas can be useful, because they may spark up a greater one and make you realize something that you didn't beforehand. Planning is a step that is often skipped and overlooked. It's understandable that you'll be eager to start manufacturing your robot as soon as possible, but if you want your robot to be successful, you need to first set short-term goals in order to meet your long-term goal. Planning is just listing out the things that you need to have for your robot. To create a proper planning schedule, you need to keep your eyes focused on the big picture and pace yourself. If your goal is to make world championships, then plan what stage you want your robot to be at for each league meet and regional/state competition. And I almost forgot, when you plan, make sure your team has access to all the required materials you need to build your robot. Also make sure that all the materials you use are within FTC legal restrictions. The last thing we want is for you to face at a meet one day and have a nuclear reactor acting as your power supply. But you probably get stopped by robot inspection before that happens. Now we finally get to the exciting part, which is building the robot. Later on in the video, my other teammates will go more in depth in regards to the mechanical aspect of the robot by offering some building tips and instructions. Besides that, I also have some advice to give you as you construct your bot. One being a reminder to always wear your safety goggles, whether you be on the field, in the pit area, or in your team's robotics lab or place of meeting. You must always wear some form of safety goggles whenever mechanical work or robot testing is being done. Something to keep in mind while building is that up until now your possible solution is just a hypothesis until you have proven it to be a legitimate solution. The way to prove this is to run tests on your team's bot once you feel like it's ready. These tests can be done either during one of your team's meetings or an official league meet. However, while evaluating the results of the test, it's best to remember that you should always evaluate your bot's performance based off of facts, not emotions. It's your team's robot, not your own. So it's best to use methods that will benefit your team rather than methods that only came from yourself. This is the step I mentioned at the beginning of the video that wasn't shown in the chart. Before moving on to the final step in the design process, relax for a minute or two. There's a theory that the more time you spend on the robot, the better it will become, but I can very well tell you that that theory is false. Our team thankfully knows when a break is needed, and because of this, the work we do is more efficient and our team bond is stronger. It also gives us an excuse to act like children every now and then. After you've had your break, you can finally move on to the last step, which is to do it all over again. As you saw on the chart at the beginning of the slides, the design process is almost like a never-ending circle. It's not new for a candidate solution to not work the first time, so when that happens, it's only natural for you to take what you learned during the testing and evaluation step, and then make any needed improvements to your original design. However, if you happen to get lucky and succeed with your design on your first trial, there's nothing stopping you from making your design even better. Our team's robot for FTC Skystone went through several modifications before it came to its final design for the regional champion.
Once you have completed your design and tested a few prototypes to verify that your design will work, check to make sure that your team has all the pieces that your design requires. Our team finds it helpful to lay them out in the shape of the chassis to get a visual image of what pieces we might still need. Also, keep in mind that it is crucially important that your chassis fits inside the First Tech Challenge size limit of a maximum of 18 inches in 3 dimensions. Check the game manual to make sure that your design doesn't break any other FTC rules or guidelines. Rev corner brackets are one of the most common pieces used by First Tech Challenge teams when attaching 2 rev extrusions at a 90-degree angle. They are relatively strong and take up a small amount of space. Attaching a corner bracket to your robot is quite easy. First, prepare the bracket by inserting 2 screws into the screw holes, then add a nut to the screw closest to the corner, and then the one farthest. Finger tighten the nuts by rotating them clockwise on the tip of the screw. Once both nuts are on, your piece should look somewhat like this. Now, it's time to attach the corner bracket to a rev extrusion, which is the basic aluminum building material provided by Rev. Since the nuts are still loose, it's easy to slide the bracket onto the end of the extrusion. Once your bracket is positioned like you want, tighten the nuts down with a Rev nut driver, Be sure to only tighten until they are snug. Don't over-tighten, as over-tightening could damage parts or even strip threads, causing your assembly to fall apart. Once your bracket is fastened to the rev extrusion, slide 2 screws onto the second extrusion. Line up screws with the screw holes on the bracket and push them through. Then, tighten them down with nuts. Once tightened, you should have a secure 90-degree angle joint that can be used on your robot.
Another common piece in the rev kit of parts is the angle bracket. They are commonly used to attach parts at specific angles, or to reinforce previous connections. Rev angle brackets come in a variety of different angles, ranging from 30 degrees all the way to 150 degrees. But for this video, we will use 90-degree angle brackets. Since our rev extrusions are already joined with an inside corner bracket, we will use the 90-degree angle bracket to strengthen that connection. We will start by sliding screws into each of the extrusions to mount the bracket. There are many screw holes on the bracket, however, it is not necessary to use all of them. Keep in mind though, that the more connection points that the joint has, the stronger the connection. Line up the screws so that they align with the screw holes on the bracket, then carefully place the bracket over them. Once the bracket is placed, tighten it down with nuts. Again, remember, only tighten until the nuts are snug on the screw. Do not over tighten.
To assemble the rolling wheels, first attach a collar to the end of the axle. Next, slide an omni wheel onto the axle. Omni wheels are the wheels with rollers around the edge. Next, slide pieces onto the axle to give space between the wheel and the robot chassis. If your team does not have any rev spacers, washers or collars will work as a substitute. Now, add a plastic bearing on the axle. Then add a bearing pillow bracket with another plastic bearing for the other side. Don't forget to attach screws and nuts to the bracket so that you can slide it onto the chassis when the wheel assembly is complete. Last, add one more collar to hold it all together. Now slide the assembly onto your chassis and tighten it down. To attach a powered wheel, the first step is to attach the motor bracket. Next, mount the motor using medium-length screws. Our team likes to use a 20:1 HD hex motor to build a fast robot. After sliding the wheel onto the axle, secure it with a collar. Be sure to tighten the set screw in the collar, but don't over tighten.
This is the chassis that our team built. See how the corner brackets are used to join the sides of the frame, and the angle brackets are used to reinforce the connections? Also note how the wheels are mounted, with collars to keep the wheel from falling off the axle. An extra extrusion in the middle of the chassis will serve as a mounting place for the electronics. Now that the frame of our robot is completed, we will mount the electronics. For this, we will need a rev expansion hub, as well as a plastic rev mounting plate. First, use some long screws to attach an expansion hub, and then some shorter screws to attach a plastic plate that the battery will fit on. The battery and phone can be mounted here and secured with Velcro, although a phone is not necessary if your team is using a rev control hub. The next thing to do is to plug your wires into your motors and rev expansion hub or control hub. For each wire, plug one end into the hub and the other into a motor. Before plugging the wires in, be absolutely sure that you are plugging them in the correct direction. The last thing to do is to secure your wires with Velcro so that they aren't damaged when the robot is moving. If they drag on the ground or hang outside the frame of the robot, attach them more securely.
Thank you for watching. We hope this video helped you in your robot assembly. We wish you luck on the upcoming season.
If you have any questions or comments, you can contact our team from our website. Select our Contact Us page and fill in the information boxes. We will assist you with your question as soon as we are available. We look forward to hearing from you.